Ladies and gentlemen, we're going to do a better job tonight talking about rotations on the coordinate plane. Rotations, it means we rotate something. Think of a knob that you are asked to rotate or turn. Okay, we're taking a point and we are rotating it about a point. That means if we have a point right there, and this is the center of my circle, and I have a point located out here, you want to imagine that these points are kind of tied together by a rope, and this point out here is going to rotate around. It's going to rotate around this middle point right here, just kind of like the Earth rotates around the sun. So if this is the Earth, this is the sun, they're kind of tied with a rope, and this point right here can rotate in a perfect circle any direction around our center point, the sun. That's what we're talking about when we say rotation. We're going to move on a circular path around a center point. Okay? So hopefully by the end of today we're going to be able to say I can rotate a figure about the origin. That means the origin, 0, 0, that point in the middle here. We're going to be able to rotate a shape around that point. That means in a circular motion around this point, we're going to be able to rotate it. Secondly, hopefully we'll be able to say, I understand that when a rotation takes place on the coordinate plane, the figure has only been rotated around a center point. But the side lengths of my figure and the angle measures are still the same size. So even if I've moved a figure from over here, to over here, that's fine. But the side lengths and the angle measures, the shape is still the same size. Okay? So here we go. Just a simple definition for rotation. A rotation turns a figure with respect to a point that is called the center of rotation. Okay? So imagine I have this random triangle here, which I'm going to erase in a minute. And we are going to, in order to rotate this, we are going to turn it with respect to this central point, our origin. So remember, if we had a rope tied around both of these, we're going to rotate this with respect to that center point. Okay, just like this, in this motion. Somewhere, we're going to rotate it somewhere around that center point. Okay? That center point we call the center of rotation. So that's all we're doing here. Now, let's look at a couple other things. To rotate a point, and normally we're going to talk in increments of 90 degrees. We're only going to talk about rotating figures 90 degrees, 180 degrees, 270 degrees, or 360 degrees, because that's what makes up a circle. Okay, that's broken into fourths. To rotate a point 90 degrees counterclockwise about the origin. This is what you're going to see. If you have an ordered pair, any ordered pair, in order to rotate that ordered pair, that point 90 degrees counterclockwise, so if my point's right, well, I'll use our point down here, 3, 2, 1, 2, 3. If we have that point right there, and it's rotated counterclockwise, that means we're going to rotate it this way. It's the opposite way around the clock. Okay, so to rotate it about 90 degrees around the clock, all you're going to do is flip-flop. If you notice, x, y is our normal ordered pair. You're going to flip the x and y, and you're going to negate the y value. So that means 3, 2 is going to be flipped, and your new x value, or your original y value, is going to be negated. Since it was a positive 2 here, it becomes a negative 2 here. Now, this will make sense once you put it on the graph. Here's our original point, 3, 2. Negative 2, 3 is right here. Well, guess what? If your first point was here in quadrant 1, a 90-degree rotation better put point 2 in the second quadrant. Okay? Because that's a fourth of the way around this circle this imaginary circle that we're forming around the origin right here. Okay, so that does make sense that it would land about right there. Now, to rotate a point a full 180 degrees counterclockwise about the origin, That means you're going to fall somewhere over in this quadrant because you should be halfway across the circle, although I'm going to use a different point now. What you're going to need to do is flip your x and your y from your original ordered pair. That would get you 90 degrees, and then you're going to flip it again. Okay? So we're essentially, from our original point, we're doing two 90-degree rotations. So that means our x and our y flip-flop, just like they did here, and you make the y negative. And then if you were to take your new point, your negative y x, and go 90 degrees further, you now have your x and y's flipped again, and now your x is negated. So the shortcut is just to remember that if you're going a full 180 degrees, keep your x's and y's in the same spot, but make them both negative. Negate them. So that means negative 4, 5. Oops, that's not correct, Mr. Dudek. Negative 4, 5, if we graphed it. Let's do that. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right there. If we're going to take it 180 degrees, and we follow our rule, it should end up, well, we leave our x the same, except we negate it. So it was a negative 4, now it's a positive 4. And our y stays in the same spot, but it needs to be negated. So that's going to be a negative 5. And I'll finish off the parenthesis there for you. So our new point, that's 180 degrees around the circle, should be at 4, positive 4, 2, 3, 4, negative 5, 2, 3, 4, 5. Doesn't it make sense? Whoa. Doesn't it make sense that our points are directly through the center, like 180 degrees around a circle? Doesn't it make sense that they're directly across from each other? That means you probably did this right, guys. So let's continue on to actual figures, not just talking about points. Here we have an example. Example 1. The vertices of a triangle, or of triangle RST, are negative 3, 1, negative 2, negative 4, negative 1, negative 2. If the triangle is being rotated 90 degrees counterclockwise about the origin, find the vertices of the image. Remember, folks, from yesterday, the image is simply the new figure after you perform your transformation. So yesterday we talked about translations. The new figure was the image. Today we're talking about rotations. The new figure is going to be, it's still going to be the image. Okay? So let's move them 1 point at a time. In order to rotate this point R, negative 3, negative 1, our prime, if you notice I'm writing up above, we should be flipping our x and a y, and we should be negating the original y. So this was negative 1, it becomes positive 1. And this was negative 3, it just moves here and stays the same. Because according to our notes, that is how you rotate 90 degrees. So I'll take my r, I'll move it to 1, negative 3. I've moved 90 degrees. And remember, what do we label that guy? Not just r, but r prime. Now let's go on to s prime. How do we get s prime? Well, flip-flop our x and our y, and our old y that's becoming x, you got to make it, you got to negate it. Since it was negative 4, now it becomes positive 4. So s prime, I'll write it right here for you, it's a little easier to see, should become a positive 4, and then still a negative 2. So 1, 2, 3, 4, negative 2. Remember, what are we going to call that guy? Not just s, but s prime. And then let's go on to t prime. Same thing. Flip-flop these guys and make the new x negative. So since it's already a negative 2, a negative negative 2 makes positive 2. And our negative 1 stays the same, but it becomes our y value. So t prime is at 2, negative 1. That is t prime. If you want to, you can draw your lines in here nicely, beautifully. So I've literally taken, here's my center of my imaginary circle. I'm trying to rotate around that central point there, the origin, and all I did was move these guys each 90 degrees. Okay, so this looks good right here. Let's jump on to another example. Graph the triangle ABC with vertices 3, 0, 3, -3, 1, -3, and its image. Remember, the new figure now is the image. -3, 0, -3, 3, and -1, 3. Okay, so we've done that. We've graphed all that. Now the question says, find the angle of rotation about the origin. All right, think about it. Did you rotate 90 degrees? Because if you went 90 degrees, since if I went in a full circle, that makes 360 degrees. 90 degrees rotated should end up like right here, a fourth of the way around the circle. And if I continue to go, 180 degrees would be directly across the circle. So it looks like A has been rotated halfway around the circle, or 180 degrees, doesn't it? Let's check on the other 2 points. B, if it's rotated 90 degrees, it should fall somewhere up here, because that's a fourth of the way around the circle. And then if you rotate another 90 degrees, oh, there you are, halfway across the circle, there's B prime. So it seems pretty obvious that our angle of rotation about the origin should be 180 degrees. Okay, all of our points were moved halfway around this imaginary circle that we have here. Okay, remember the center point being the origin. So let's sum this up. What did you learn today? Well, the question that you should all be asking yourselves, and hopefully you can answer, is, can I rotate a figure about the origin? Can I move a figure around the origin? We did it here in example 1. We did it here in example 2. Actually, it was done for us here in example 2, but I'm pretty sure you guys could have done that. Okay? Because using your notes, if you want to rotate something 180 degrees, take each point, keep the x's and y's in their same spots, and just negate the new values. So -4 would become +4, +5 becomes -5. Alright folks, we're going to have some good practice on this tomorrow. Hope you have a great night.